This is the binomial theorem. That's the name of the section, but we're not actually going to use the binomial theorem. This section teaches you two different ways to expand binomials. One of them is the binomial theorem. The one we're going to use is Pascal's triangle. And you've probably seen Pascal's triangle, but I'll show it to you in a second. What we're going to use it for is to expand binomials. If we had a binomial, x plus 6 squared, you could write it out as x plus 6 times x plus 6 and use what method from there?
FOIL.
FOIL. And you end up with x squared plus 12x plus 36. Okay, but what if you had something like this, x plus 6 to the 5th? And you did the same thing. You would have to write it out 5 times, FOIL the first two, take that result, multiply it to the third, take that result, multiply it to the fourth, take that result, multiply it to the 5th.
We're not going to have to do like a lot of that.
Well, you won't have to do this at all, because we're going to learn a different method. So this is, if we did it this way, then that would take a while.
Yeah.
But instead, we can either use the binomial theorem, or what we're going to use is Pascal's triangle. So let me show you Pascal's triangle. And right here are the first 7 rows. They don't consider that top one a row. Okay, that one by itself is not a row. Your rows don't start till here. But you got to be able to come up with this triangle on your own. We start with a 1, then we go 1, 1, 1, 2, 1 for row 2. Row 3 is 1, 3, 3, 1. Row 4, 1, 4, 6, 4, 1. Does anybody see the pattern?
Would it be a good idea to write this down?
Yeah. Well, you don't have to. It's in the book. You should be able to come up with it too. Does anybody see the pattern?
Not quite.
Who does? Yeah. What would the row 8 be if you see the pattern?
1, 8, 24.
No. 1, 8 is correct. What's the next number? 28 would be the next number. All you're doing to get like this number, I add those two together. To get this, I add those two. So what would go here? 28. 56. 70. 56. 28. 8 and 1. So that's how all you do. That's all the way down.
You would add what two numbers?
The two numbers above it. So that to get the 21, I add these two. To get the 35, I add those two. Okay? Alright, and what these numbers are going to represent are your leading coefficient when you expand out a binomial. For example, if I had the first one, expand a plus b to the third, I'm going to use row 3 of Pascal's triangle, which is 1, 3, 3, 1.
Are you going to give us the triangle on the table?
No.
Why?
You can come up with a triangle. I just told you how to come up with it. Okay? So the 1, 3, 3, 1 are going to represent your leading coefficients. Look at my final answer. I have a 1, a 3, a 3, and a 1. This is my final answer. Now, to get the terms, you know that the first term, you should know that the first term has to be a cubed, always, because of this. And the last term you have to end up with b cubed. All right, and you can see that when you multiply out a binomial squared. You end up with a squared, or you start with a squared, you end up with b squared, right? Let's go back to that for a second. Let's go back to that first page. See, we start, our first term has to be this number squared, our last term has to be this number squared. So if I multiplied all this out, what's my first term going to be? X to the 5th. What's my last term going to be?
6 to the 5th.
6 to the 5th, whatever that is. Okay?
I'm sorry, I didn't get that.
Which part?
I didn't get what you were trying to say.
Just know that whatever exponent you're raising it to, your first term has to be this number to that exponent, so you would be x to the fifth. Your last term out here would be this number to that exponent, which is 6 to the fifth. Same thing up here. X squared, 6 squared. Here's x squared first term, 6 squared last term. Okay? Alright, so to get the middle terms, all you do, since I started with a cubed here, I work my way down with the a's. So I work my way down to a squared, a to the first, then a to the 0, which is 1. Okay, with b you do the same thing, but reverse the order. B cubed, b squared, b to the 0. See how easy that is? Here, x plus 4 to the fourth, expand that. We're going to use row 4, which is 1, 4, 6, 4, 1. Those are my leading coefficients, which I put here in blue. 1, 4, 6, 4, 1. You know to start with x to the fourth. You know to end with 4 to the fourth. Now with the x's, you just work your way down. X to the fourth, x cubed, x squared, x to the 0, which is 1. With the 4's, you work your way down another way. 4 to the fourth, 4 cubed, 4 squared, 4 to the 0, which is 1. Okay, but then you have to multiply, you have to simplify each term itself. So I multiply this 4 and this 4 to get to 16. Multiply 16 and 6 to get 96. I multiply, what's 4 cubed? 64 times 4, which is 256. 4 to the fourth is 256. That's a lot easier than doing x plus 4 times x plus 4 times x plus 4 times x plus 4. Okay? Now, if it were a minus, you still follow the same rules that we have. The only thing that changes is we follow a pattern of plus minus plus minus. The first term has to be positive. Next term minus, plus, minus. So if it were to the 8th power, you would do plus minus, plus minus, plus minus, plus minus. Okay? Just follow that pattern with your sign. But you still do the same thing with the variables. Since it's cubed, we use row 3, 1, 3, 3, 1 is my leading coefficients. Okay? X cubed, x squared, x, 2 cubed, 2 squared, 2. And this is what you end up with. X cubed minus 6x squared plus 12x minus 8. Question? Yes?
You figure out which row you use by the exponent?
Yes. The exponent tells you what. Since this is to the fourth, you use row 4. These two were to the third, we use row 3. All right, let me give you some sample problems.
Can you?
Yeah, that's still up there. Are you everybody done writing that down?
Yes.
Yes?
Yes.
I tried these two.